Hello everyone, today we're going to discuss a bit about security in web applications. There are a series of things which are of interest to us. So typically, on the one hand there are these general issues that we have to address. The first issue is the fact that the HTTP protocol is a text protocol and it sends clear text, which means a man in the middle, somebody uh, which forwards the messages from the source to the destination might read them. So that's a problem, and the way to handle this is by securing communication. The second issue, which is again a general issue, is the fact that I want to control access to my application. And there's various levels of controlling access, and we're going to see them one by one. The third issue is that I might have some common vulnerabilities. Now, part of this we've addressed. We're not going to go into them, at least not today, because to take an example, if you think about something like Sql Injection, which is user input, which is actually executable SQL code. This is we've actually externalized this, so to speak, in the sense that we've tasked Sqlize with doing this. Sqlize does sanitization for us, and this is basically a good deal. Of course, we also have to monitor if the guys maintaining Sqlize haven't made an error somewhere. And there are general vulnerability databases such as SNCC. I think this is. So there's if you really have something sensitive, you can monitor stuff which is called CVEs. Right. So this is cybersecurity vulnerabilities, and there are lists of these. And for Node, there's SNCC, I think it is. Yes, Node.js vulnerabilities. Right, so I can look for a vulnerability DB and see if anything I'm using has such a vulnerability. Right, and we're gonna look like for Sqlize, for example. Right, and I can look over them and see what versions they affect if we use that version and so forth. For example, none of these is for our current version, I think. So this we've externalized. So let's get back to the main topic, right? So the first thing I have to handle is securing communication. And there's two aspects of these. This is done via HTTPS. Now I remind you that HTTPS is basically the same protocol as HTTP, with the difference that instead of using TCP for transport layer for actually carrying the data on the transport layer, it uses something called TLS, so transport layer security. So my application is going to be the same whether I'm delivering it over HTTP or HTTPS, which is a great advantage. I don't have to rewrite it or anything else. But there are two issues here, right? So one issue is actually transmitting data from A to B through some sort of intermediary node, which is C. The second issue is the identity of the destination, right? Because there are a bunch of possible attacks which rely on falsifying the identity of the destination. And to describe a real attack of this class to you, there's something called DNS poisoning, right? So when a user tries to connect to their bank, they're not going to write the IP in the address bar. They're going to write is a name such as ing.raw or raiffeisen.raw or whatever. And then the browser has to ask a DNS which is the IP corresponding to that name. Now, DNS poisoning assumes that I'm attacking the DNS servers in such a fashion that I falsify their records, which means they're going to give the user's browser, a wrong IP. And on that IP, the attacker has put a clone of the original site. Right? So I go and it looks exactly like ing. How do I know it's not ing? Well, this is the second thing HTTPS is going to do for me, which is I'm going to get a partial solution to what is called the trust problem, right? So the question is, where does trust come from? And so if you go and present yourself to somewhere and to say I am my name is whatever it is, they might not trust you, right? And the way you prove this is via something which was emitted by a state, right? You have an ID card, and the ID card says that you are that person. Now, the internet has a similar trust problem, and I have to when I go to a website and they pretend to have a particular identity, again, I want to have some sort of certification that the identity is the one I'm assuming. And to do this, again, we're going to use on HTTPS, we're going to use certificates, digital certificates. Now, these certificates might ultimately be emitted by a state, and then they tell me something about identity, right? They say this is the company they pretend to be, or this is the person they pretend to be. But on the web, I'm not really interested in that. I'm interested in if my interlocutor in my conversation is actually who I'm assuming them to be, right? If they're the guy who initially had the server. And for this, actually, you can see this in the share. We can use a certificate, a free certificate from Let's Encrypt. Now, this is a certificate service which is maintained by the Electronic Frontier Foundation, and which tells me that they have access to the server, basically. Right? This is what I can take out from this. I don't know anything about the identity of the person or the company, but I do know that it's the right server. Now, in our example, we're going to use what are called self-signed certificates, which don't have any trust, but they are going to encrypt the connection. Now, as for the connection encryption, the way this is going to work is I have two different things. One is the encrypting the data, and this can be done symmetrically, right? I know a secret, and the server I'm talking to also knows the secret, the same secret, and I can encrypt something with my secret, send it encrypted, and they can decrypt it with their copy of the secret. Unfortunately, this has an issue, which is the fact that this works fine as long as the secret can get to the destination. And unless I want to have somebody go with with a little bag with the secret written down on paper, probably I'm going to need a key exchange mechanism. And this happens through something which is called asymmetric encryption. So I have a private key, and whatever I encrypt with my private key can be decrypted with the public key. And you see, this actually also gives me something about identity, because I know that if I can decrypt it validly, I know that it was encrypted by a particular somebody having a particular key. Radio. So one sec. So let's just write an HTTPS server, and I'm going to write it to the self-signed certificate, and we're going to have one additional requirement, which is the server has to work both on HTTP and HTTPS, and it has to be the integration has to be seamless, right? So if the user goes to the HTTP version of the server, I'm going to seamlessly redirect them to the HTTPS version of the server. Right, so let's say HTTPS example. This is going to be an express application, exactly like we had in previous courses. So let's just write it. I'm just going to copy paste some of this. We're going to write just the part which is especially interesting. So first things first, I'm going to need Express and to create an app in Express. Now, typically, I would have had this app act as a server, so have it listen to a port. Unfortunately, in this situation, I need two servers, right? So I need an HTTP server and an HTTPS server, which means I can't use the app as a server, but I'm going to have to, or rather, I'm going to have to create a couple of servers, one for HTTP and one for HTTPS. And I can do this with something which is included in Node, which is these two packages. And these handle server creation. So to create an HTTP server, I can just do http.create server of app. And that's it. And then the server can listen to the same old port, which is going to be the typical web development port, right? So it's 8080 instead of 80. But we could put it on 80 as well and would have no problem. We also need, however, an HTTPS server, right? So I might try to do something like this, but this is not going to work. Now, assuming we've created the server correctly, this is going to listen on the development port for HTTPS, which is 8443, because the production port for HTTPS is 443. Now, the reason why this is not going to work is I wouldn't be able to figure out how to secure this, right? So what I'm going to need is some credentials and the app. Now, the credentials are going to be an object, and they have to have a couple of things. So they have to have a key, my private key. They have to have a certificate, which certifies my identity. And optionally, they might have additional information. So let's handle that. Well, my certificate, self-signed though it may be, actually has an Ssl passphrase, right? So it has an additional layer of security. And let's say we hold this in a .m file. Now I can put something, so it's Ssl passphrase, and it's the uber secure passphrase of 1234. Right, so in credentials, I'm going to need the certificates and the passphrase. Now for the certificates, like I said, I've generated them with OpenSSL, so they're self-signed certificates. We can't actually use Let's Encrypt certs on localhost, right? Which is why we're not using them. But we can easily use them in production. They're generated via a utility which is called certbot. But since what they establish is that I own the server, I can't own localhost. It's not a valid name, right? So here I'm going to have a cert PAM, and we're going to see them because there's nothing actually secret about them. Like I said, they're self-signed. And if we look at them, let me just find them. One sec. So this is the key, and this is going to be and the cert. Let me just get the cert. So they're text files. Something to note, right? They're just text files. Right, so I have to load them, and in order, so this is HTTPS create server, sorry. I have to load them, and in order to load them, I'm going to use a module which is installed with Node, which is called the FS. So it's FS, and FS has a function in it which is called has a bunch of function in it, of course, but it has read file sync, right? So this is just reading a file synchronously. Now this also has its alternate form, which is with promises. However, we are not interested in that. If this fails, it's okay for the server to crash, right? Because we don't actually want to run the server unless we've successfully loaded all resources. As for the Ssl passphrase, we're going to use .env, and I think we've used .env previously. Now the env is going to be the list of key value pairs which represent the context in which our server was run. Now this is populated by the operating system, and if you've looked at I think it's the React flow, you have or somewhere in the SQLized flows, you have a deployment on Heroku, for example, and there we took something from the env. We can access it through process.env. So what .env does is it extends the env. So apart from the keys which existed from the operating system, I have some additional keys, and in my case I have Ssl Passphrase. So I can now build my credentials. So cert is going to be certificate, key I think is going to be private key, and Ssl passphrase is process env Ssl passphrase. We also might need something to do with our server, right? Because our server doesn't do anything. So let's have a ping. just so we have something to request. Right, so we can actually see this in action for now. I'm not in the right directory. We have to install a couple of things. So express and .env, and now we can run our server. Right, unable to get passphrase. It's process.env Ssl Passphrase. I don't know if I've written it correctly. Let's just check it out. It is correct. So server.env. Okay. Maybe it's not that. Let me just check. Oh, it's just passphrase. Right. Radio. So we can now go to localhost, and we're going to go to localhost in two fashions, right? So we're going to go to localhost on HTTP, and this gives me pong. That's fine. And if I look here, my connection is not secure. That's because I'm transmitting stuff over HTTP. Let's go to the same thing but via HTTPS, and I get an SSL protocol error. Right. Now it's HTTPS. It's on 8443. Right, and I also get pong. Now, act is even if it does say not secure, it's not that unsecure. What's being lost here is the fact that I don't necessarily know who the server is, but the connection is encrypted. So it says it's not secure because the certificate is not valid, right? And this is my certificate. So if I had a real certificate, it would work. Now there's one last thing to do. So I'd like my application to only communicate over HTTPS, but I wouldn't want the user to get an error if they write the address with HTTP. So the way to do this is to use a middleware, which is going to redirect stuff to HTTPS. So I'm going to say get for all things. And here we're going to wonder if the protocol being used is HTTPS. All right, so we're going to say if request.protocol is HTTPS. Now our solution is somewhat naive. So if it is for HTTPS, that's fine. But if it isn't, we're going to redirect it to HTTPS. Uh, if the only alternate protocol is HTTP, we're going to have no problems here. But if we're using something else, it's not going to work, right? So it's a simplified example. So we're going to say res.redirect, and now we need to build our new address. So it's going to be HTTPS. Then we need the server. We can get it from request headers host. But unfortunately, it also contains the port. So we're going to say split of this of 0. No, of 0, which is going to be the host. Then we're going to put our own port, which is going to be our HTTPS port. And then we're going to use the paths because they're not going to necessarily request the root of my application. They might request something else, such as ping. So if I go here and now I go to HTTP, I'm going to notice the actual communication happened on HTTPS. So that handles this part, right? So I have a somewhat secure communication. What about the other part, right? I have to control access. Now, there are web applications where everybody has access to everything, right? Everything is public. But this is not the typical case, right? It's probably there's going to at least be some part of my application which is only going to be accessible to authenticated users, right? So only users which have logged into my application. Now, let's see some naive solutions and then let's implement our own solution and evolve from that. So what I want to have happen is to, whenever a user makes a request to my application, to be able to check some condition. Now, the easiest way of doing this is there's a mechanism which is included in HTTP, which is called basic authentication. And if we look for the idea of express and basic authentication for the combination, we're going to find a middleware for this. Now, why does this make sense? Well, I want to separate the security logic of my application from the business logic, right? I want to have the business logic testable separately, and then add the security as something which is called a cross-cutting concern. So security is going to affect a bunch of things in my application, and I don't want to write it everywhere. I just want to write it in one place so I can modify it, monitor it, etc. If I write security logic everywhere, I'm going to miss a couple of spots, which means my application is going to be insecure. Right? A chain is as strong as its weakest link. Right, so let's see the most naive solution and continue from there. So we're gonna say let's call it simple auth. Um, so again, we're gonna have a package JSON and a server.js, and we're gonna have a couple of dependencies. Let's just install them. So I'm securing Express, so Express, and we're going to use a middleware written by somebody else, and we're going to rewrite it then so we understand how it functions. But it's Express basic auth. Right, so back to our server. What we're going to do is we're going to have our app. We're not going to bother with a separate server, so we're going to say just app.listen on 8080. We're also going to need our little ping. Let's just take it from here because this is what we're securing. And now let's just use the package and its middleware. So we're gonna say basic auth. And I said it's a middleware, so well, it's not a middleware. It's a function which constructs middleware. So it's going to be basic auth of some parameters. And in this case, the implementation is really naive in the sense that it assumes that I have the list of all my users in memory, no matter where I took it from. So let's have an admin which has a password which is a super secret. And that's it. A couple of problems here. So the mechanism is not transparent, but we're going to see this shortly. But one problem is that I have to hold all my users in memory. I have an application which has 46,000 users. And the more users you have, the more this seems like a worse and worse idea. Right, for now, however, let's just see it in action. So we're gonna go here, and if we now make a request to ping, we're going to get a 401, right, with unauthorized. Right, so our middleware, no matter how it works, checked some condition, and it decided to not let us continue. Right. So let's now fix this. So since this is a mechanism which is included in HTTP, we're going to have a separate tab in Postman here. So we're going to have basic auth, and we can write admin super secret do update request, and let's see what happened. Well, a header was added which says authorization. This is the key, and the value is going to be basic followed by a space followed by something. Now that something is the username colon the password, all of this being a string which is base64 encoded. And I can now see that I actually get pong. Right, so this is something that exists. Um, let's see how it's built, so to speak. Let's build our own alternative to this, assuming that, for example, we would not keep our users in memory. But the approach itself is not ideal, and we're going to evolve from it later. But for now, let's just take this and make a server 1. In fact, let's just make a copy. Let's run our server 1. And we don't want this, so we're just gonna say app.use and have our own middleware. So request response next, just so we see how such a middleware would work. Again, the logic is going to be separated from the separate from the business logic, so the ping, so that we can edit it in one place. So first off, we have to wonder if there's a header, if the header we need exists. Right, does this header exist? If it doesn't, there's no point in continuing, so rest.status. 401 is typically the code we want to, we have to send the client error, and 401 is typically the client error code we want to use because it means unauthorized. Now, if the header does exist, we now have to process it manually, right? So we had an encoded part, so we know it looks like this. It's basic space something. So we're gonna say encoded is request headers authorization split of space, and we care about the second part. Now that is base64 encoded. So decoded is going to be, we need to convert this to an actual string. So we can do it with buffer, which is an object which exists in Node, from something. So it's from encoded, and the encoding is base64. Now this is fine, we've decoded it, but we've decoded it as an array of bytes. This is what buffer is. It's basically an array of bytes. It's an object, but it contains an array of bytes. So we need it as a string to be able to better handle it. So to string of UTF-8. Now UTF-8, because we want our users to be able to have their their smiley face users, or their punctuation signs, their letter punctuation signs. You know. So this is going to handle all of that. So from this, we can extract the username and the password via destructuring. So we can just say decoded.split of colon. And now, we're going to hard code it. So we're going to say if username is admin and password is super secret, we can continue. Otherwise, we're just going to say the same unauthorized message. So what we've basically done here is clone express basic auth. This is not going to be our final approach, but let's just see it in action. So what should happen is if we perform this request again, it should work, and it does. Now, if we change something, so for example, if we do something wrong, unauthorized. If we clear it, unauthorized. Okay, so this is one way of doing it. However, typically, I'd want to have something else. So what I want to have happen is I'd want to, if I think about my application is going to have a bunch of parts. So there's going to be a public part. There's going to be a private part. Now in the private part, possibly, I'd want to have multiple types of users. Now in the multiple types of users, I'd possibly want to have ownership. What do I mean by that? So my application is going to have a public part. So if I want somebody to register, obviously they're not going to be able to provide me with the username and the password. If I want somebody to log in, initially they will provide me with the name and the password. Um, However, what I'm going to do in this case, instead of just leading them to the application, is I'm going to give them back a token. Now, this token is going to be a time-limited key for which they can access the private parts of the application. Right, what about different types of users? Well, if I think about a typical application, it's probably going to have one admin area and a general user area. So I'm going to want to be able to differentiate access between different roles, between different types of users. Now, what about ownership? Well, if I have an application where people upload photos, the fact that you can delete a photo doesn't mean you can delete any photo, right? You can delete your photos, but not any photos. So I want to be able to reflect this. And this is a sort of a minimal core of providing access control. Uh, when when stuff can be taken further than this, I'm going to mention it and we're going to talk about it. So first things first, I'm going to need we're going to build a custom auth, and let's just have our let's say that's primary pieces in place. One sec. Right, so we're going to install them shortly, but we're going to need Express for our app. Now, probably we're also going to need some sort of body parser. Body parser is now included in Express, so we can do this. We also need some logic to control access to, so we're going to go with good old ping. So let's take ping from here. And now we can continue. So let's think about it. Where are we going to hold our users? Well, we said that it's a bad idea to hold our users in memory, so we're going to want to store them somewhere in a database, presumably. We're going to use SQLite. Although there's no difference if we switch to something else. Now we're going to need some sort of representation of a user, right? So our user is going to be something like this. One sec. And so we have a username and the password, and I give them a token, right? So they initially provide the username and the password, and then I give them back a token. Now I also mentioned that I might want this token to be time limited. So let's also put it time limited just so we don't have to generate the database again. So we're gonna have a token expiry, which is equalize date. Right, so what happens when the token expires? Well, typically an application using my API is going to redirect the user to log in again so they can get a new token and continue. We're going to see probably next time something which handles this redirect logic. We don't have time to do this today. So we're just going to handle the backend. As an aside though, anything I do on the front end is actually related to ease of use, not security, right? Because whatever checks I do on the front end, the user is going to be able to circumvent them and just pass manually crafted requests. Right? So I have to handle security on the back end. Right, so we have this our user. Now we're going to need a couple of endpoints, right? So let's just let's just create a couple of things. So some of them we're just going to ignore. So what's admin related, we're just going to pretend they're not there, because we're going to need to synchronize the database and so forth. So app dot get create. And if we want to for everything to go easier, let's just have an error handling middleware. Right. So we're going to need create. We're going to need another admin endpoint which we're going to ignore, which is adding a user. So we're going to pretend this is not security related, in the sense that we need this as a pre-existing condition. Then we're going to have something which is relevant, which is the login. And for login, I expect to send a username and the password and to get back a token. And then we have this ping thing uh, we have to secure. But before we continue, let's think about it. Well, if I leave everything on the app, it's going to be really hard to differentiate between them. So I might want to group them on different routers, because I can apply middleware to different routers, right? I can say only a particular subset of these has to be secure, for example. So let's have some routers. So we're gonna say let's say auth router, which is going to handle just login and stuff. Then we're going to have an admin router, which is the part we're going to ignore. And then we have an API router, which is the part we're going to secure. Now these have to be accessible somehow, so we're going to say app use auth router on auth. Let's have admin router on admin, and so forth. And API router on API. Okay, so the only thing we're going to want to secure is the API router. The auth router is naturally public, right? Because I have to go to login to get my token. And the admin router, like I said, we're going to pretend is not involved in this. So let's before everything else, let's just see how we do a middleware to check something. So we're gonna say API router.use, and this is going to say, well, if request headers, and this is custom, so we're just going to call it auth, just to have something different. So see how we handle that. And if request headers auth is some key, then next. Otherwise, I'm gonna say 401 unauthorized. Right, so this should work out to to control the access to ping, even though we have none of the other ones. So if we go, let's just go to custom auth. We're gonna need express, equalize, SQLite 3. Do we have anything else? Not as of yet, right? Right, so we can start our server and we can check that everything's fine until now. So if we go to API/ping, it's unauthorized. But we can go here and give it a key, which is going to be our token, and it's some key. I cannot get API ping. What? All right, we have everything on app. So this is going to be, we forgot to do this. So this is going to be on API router. Post users and create are going to be on the admin router, and the login is going to be on auth router. So trying again, we're going to get pong. Right. So it's secured. If we take this out, we're gonna see it's unauthorized again. Right. So let's move forward from this. So we need a couple of things. Like we said, we have to have the user in the database, and you have to be able to create the user. Then we have to create the user, like I said. So let's start from this. Right, so this is going to be await user.create. It is called user, right? Right, yeah. User.create of request.body. We assume we don't validate anything because um, we assume that we got the right data. Then we have to do login. So for login, uh, like I said, what we'd like to have happen is to get a token, right? So we have to generate a token. How do we generate a token? Well, again, we're going to use a somewhat naive approach. This token has to be random, it can't be predictable, and it can't have collisions, right? So I can't have two people with the same token. Now this is partially true for what we're going to use, but it's included in Node, so So crypto is required crypto. Obviously, there's a bunch of packages which are going to offer me stronger assurances that everything's fine. Right, so for login, first thing we're going to do is try to find our user. If we don't find our user, there's no point in continuing. We assume that login is going to receive the credentials in request body. And now we're going to find our user. We're going to say await user.find1. Now we can't find by PK because we're going to find it via the username and the password, not via its primary key. Now, obviously, if the user does not exist, you're unauthorized or something similar. Let's find an unauthorized. Then we're gonna say invalid credentials or something. Some sort of suggestive thing for our users. Now, if the user does exist, well, in this case, we have to generate a token and save it in the user for later use. So I'm gonna say user.token is going to be crypto. Let's just save it. So we're gonna say const token is crypto dot random bytes. How many bytes? Some bytes. Unfortunately, this is a byte array, so to save it in our string, because we've defined our token as string, we're gonna say to string of hex. User.token is token, and then await user.save, and then we're going to send an answer to the user. And we're gonna say message login successful. and this would be useless unless we send the token. Right, so now the user has the token. Because they have the token, we can now look at our API router, the one which we're trying to protect, and try to protect it. And the logic is going to be similar. We're going to have a middleware which does this stuff. So let's go somewhere to the top. And this middleware doesn't matter anymore. We can still check if auth exists. But if it doesn't, we're not going to next immediately. What we're going to do is we're going to try to find the user in the database, but not via the username and password, but via the token. So we're going to say const user is await user.find1, where token is request headers auth. Now again, if user, well, for now we can just next. Otherwise, we're gonna say invalid token. So let's be more explicit. Here we're gonna say no auth header, and there we're gonna say invalid token. Right, so this should work out. Let's just test it out. I don't think we've created anything, so let's create our let's have a post to admin create get. Sorry, we put it on get for some reason. No, we forgot to put an await on a thing. Sorry, radio tables created. Let's now create a user. This is going to be just adding something basically. So we're gonna have content type application JSON, and something which the data which we need to, the information we need to create a user here. So username, and say test user, and password, and let's call this test password. Radio. So cannot post admin. It's not created users. Right, user created. Now let's try to go here, and it says no auth header. Now we might have an auth header. Let's just clear this. Sorry, so no auth, just so we have a better. I don't know why it still keeps it there. Right, so invalid token. Now we don't have a token, so we're going to have to log in, which means we're going to do a post to auth login, which is going to look very much like adding a user, right? So content type app.json, and we're gonna have to send something which looks like a user. And this should give us a token, and indeed it does. So we can now go to get API ping and send the right token and see if it works. And indeed it works. Right, so we've now successfully controlled access to our application. But let's see a couple more things, right? So the first thing we want to see, we said we want to have token expiry. Now the reason to have token expiry is that a user might log on to a device and then somebody else might have access to that device. And if the user hasn't logged off, they might be able to access their data. Now, obviously, if the token expires in a reasonable amount of time, um, they're going to have to re-log in and they're not going to have the credentials. Now we're going to use an unreasonable amount of time just so we're able to test it, but the lowest duration I might think about is something like 15 minutes. We're obviously going to put something like 1 minute because we want to see it happen. And So we're going to need to do some date comparisons, and we could do this by hand, but we'd be reinventing the wheel. There's a really mature and well-designed library for JavaScript, which is called Moment. Right. We can now restart our server, and I don't think we're going to have to add anything more. So let's import Moment here. So in order to talk about this Moment business, we're going to want to have a constant, which we got some from somewhere. We're just going to write it here, but it's probably a configuration parameter of the application. And let's call it token expiry. And let's say it's going to be 60 seconds. Now, whenever a token is emitted, right? So in out here, we're going to have to check to give it the expiry value, right? So I'm going to say that user.expiry is going to be moment. Now, if we emit tokens which expire at the moment they're released, they're useless. So it's going to be moment. It's going to be some time after moment. And the reason why moment is so awesome is that I can do something like this. So add token expiry seconds. So we now have this. Let's see if we have the right user. Yes, we do. We can return to our middleware, and if the user does exist, we can check something else, right? So we're going to check if the token is not expired. So we're going to say if moment, this is going to be the present, the now. So if now minus, which is diff user.expiry in seconds less than 0. Right, so if the token has not expired, right, because it's the present minus a future time, it's going to be negative and it's not expired. Otherwise, I said if it is expired, we're just going to do token has expired. And that should handle it, and we should actually have the data. So let's check it out if everything's valid. So what we want to do is we want to log in, get a token. Let's check that it works, and then wait some time. I'm going to just pause the recording and take any questions you might have while we wait. So let's see if this expired. Maybe it did, maybe it didn't. Nope, nope. Token has expired. Right, so it expires after this, after 60 seconds. So we have token expiry. Now let's think about something else. Let's say our users are not all the same, right? Like I said, it's the case where I have some sort of an admin and some sort of a regular user. So our users are not the same. And I have to differentiate between them. So maybe the API is only accessible to some users which are special users. Right, so let's see that. So first of all, how do I know a user is special or not? Well, I'm going to add something here which is a user type. And we're gonna say it's a SQLized string just so we don't you know, make it something especially complicated. Now we're going to have to recreate everything because we don't have the user type. But how would I use that logic? Well, the good news is I can use multiple middleware, right? So I can just, if I copy this, I can have another condition. And I'm only going to get to this condition if I pass this condition. Now, if I look at this, well, I'm finding the user here. So I'm doing for every request, I'm doing a couple of SQL queries, basically. So that doesn't seem like the best idea, right? Because I keep doing for my security bit, I'm seriously decreasing the performance of my application because I keep doing requests which are perfunctory. So what I'm going to do is instead have the user somehow pass through the middleware chain. Now, the way to do this is if everything's fine, so if everything is valid, we're gonna put it in response.locals.user is user. And this is going to make it visible within the middleware chain. Right, so here, instead of doing everything like this, we're just going to delete everything, right? And we're going to do, say, const user as response locals user, and we're gonna check its type, we said, right? So I'm gonna say if user.user type is special, then next otherwise, if they're not special, we're just going to say only special users can access this part. Right, so let's test this out before continuing. Right, so we have to create this again. We have to create a user. Now this is an incomplete user right now because they have to have a user type. And let's say this user is a regular user. And let's have another one. Let's have another one. And we're going to need a content type. And this is going to be a special user. And let's just call it special user and special password. Right, so we've created it. Now let's try to access our API from the two users, right? So if I'm a special user, I can log in. Auth login. I can log in, get a token, get back here, use the right token. That's fine. What if I'm not a special user? Well, let's try with test user. Test password. Well, again, I can successfully log in. I can get a token. I can go here. And only special users can access this part. So I successfully isolated part of my application from part of my users. Right? So if I can have admin users and so forth. That's fine. However, there's an additional problem here. Like I said, the fact that somebody can do an operation on a particular resource doesn't mean they can do that operation on all resources. So maybe for this case, what I need is some sort of minimal role model, right? Minimal permission and role model. Now, if I think about having permission on something, the way that I can represent this is I have resources, I have users, and the ability of the authorization of a user to do something to a resource is called the permission. Now, for what we're going to implement, we're just going to need these three entities. However, if I have a bunch of permissions, right, a lot of permissions, I might want to group them in permission sets, so to speak, which are called roles. And if my roles are complex, maybe I want to have role composition. So I have a role which inherits another role and so forth. But this actually depends on the complexity of the application. So what we're going to do is just users and permissions. And so let's get back here, and we're going to need a couple more entities. So first we're going to need our resources. right? And this is going to have some minimal. It doesn't matter what the resources are. So let's just do SQLite string. Now, what about permission? Well, can I have any permission possible? Can it be a string? Well, not really. I can have a limited set of permissions. So maybe I want to have a perm type, which is going to contain the possible values. For this, I can use SQLite enum. And for now, I'm just going to have read. Right. So the idea is that the user has a many-to-many relation with permission with the resource, and the intermediary entity is going to be permission. So we're going to say user has many permission. 1 sec. And resource has many permission. That's because I can abstract a many-to-many relation as to one-to-many, right? Which is what I'm doing here. Perm. Right. So now I have to have a minimal set of operations which function on resources, right? I have to at least add a resource and at least read a resource. So I can check if my mechanism, whichever that may be, is actually functioning. Now this is going to happen on API router because we only want to have our special users, um, create and read resources. So API router.post, and I can post to resources. Now this is fine, but it doesn't seem semantically alright because I said that my resources have ownership. And because they have ownership, maybe I want to write it like this. Right, so it's a resource of that particular user, which belongs to that particular user. And to read it, I'm going to have a get resources /RID. Right, so let's first create our resource. So we're gonna say let's try catch everything. So we're gonna say const resource equals await resource dot create of request dot body. Now I remind you that create is going to return whatever it created. And I need this because what I don't know from resource body is the ID of the entity that was saved. And I need it to define the permission. Now, as for the user, well, we're going to say user is await user dot find by pk request params uid. It's user without the capital. Radio. So I'm not going to check anything here, but I should check it. Right? I should check if this is an actual user and so forth. But we're going to bypass this and just write it as simple as possible. So what about perm? Well, permission. Well, it's going to be a new permission, and there's only one permission type. And then permission.userid is user.id. How do I know this? Well, I know this because I know what the convention for SQLite is, so I don't have to check. Right? I know it writes things camel case with a lowercase first letter. and permission.resource_id is resource.id. So I can now save the permission and then do something with the 201. We're gonna say message. Let's have this be a bit more explicit. Right. Now, this is a bit more complex than what we would have had if we didn't use permissions. What about this one? Well, it's going to look exactly the same as it did before, right? So there's not going to be anything special about this. I'm going to see why shortly. So we're just going to find the resource based on the ID. And either it exists and then we send it, or it doesn't and then we do a 404. Right. So how can this be not different if we want to check permissions? Well, the answer again is that I'm going to have a middleware. But this kind of middleware is going to be a bit different. Until now, we had middleware which were applied to a particular router, or either to the app or a particular router. But I can have middleware which are applied just to this particular endpoint, because any one of these, it matches method and address, and then what it actually has here is an array, is a spread out array of middleware, which means there needn't be only one thing handling this particular request, right? So in this case, I'm going to have something. So it's the equivalent of this. I can write something like this. However, I only need one, so I'm going to just say perm middleware. This doesn't exist yet, but it's going to exist shortly. Right, so let's go and write perm middleware. Well, perm middleware is going to be something of request, response, and next. And I'm going to need my user, right? Because I want to have permission of a user over a resource, which means I'm going to need my user. But I can already get my user from REST locals. Right? I know this is because if I think about how I get here, I can only do this on an API. I know that because of the previous middleware, I know that the user is special, and because of the middleware before that, I know that they're authenticated, so that it exists. Right, so having my user, I'm going to say permission, let's say, is await find one, sorry, where user ID is user.id and resource ID is request params read. A couple of things to fix here. This is a sync. This is possible that this can fail, so let's do that. Now again, two possibilities. Perm exists and then by all means go right ahead. Or perp doesn't exist, and then we're going to say response status 401 message, you can only view your own resources. Right, so that's that. Let's just test it out. So we've modified a couple of things, so we have to recreate everything. We have to add a couple of users. We're only going to bother with special users because otherwise they can't get there. So I have test user, which is going to be special this time. And I also have special user, which is also going to be special. Now let's assume we log in with this one. We have a token. I've used that one because I recreated the tables. I know what ID it has without checking, so it's 1. So we're going to add a resource. We're going to say post. Right, and here we're just going to have content. Some content. Oh, it's in the API. No auth header. Right. That's because we forgot to put out token. Token has expired. Right. Let's handle this. I'm going to enlarge the. We can't do this with 1 minute. So let's re-log in. I'm gonna get a valid token. Right. Resource 1 created for user 1. So let's just read our resource now. And we need the auth. Nope. Right, so we can read our resource. Now what about special user? Let's log in with special user and try to read this particular resource. Oh, as an aside, we shouldn't store password in the database. We should just store hashes of passwords. But, for this example. Okay, so let's try to get our resource. What did I do? One sec. So it's special user, special password. Right. It seems we have a bug. Let's see what it consists of. Right. So let's see if it's. Oh no. Oh, we did per middleware. We did use it. All right. So first, we're going to log in with this guy. Oh, let's start from the top. Sorry. So we're gonna use this test user. Then we're going to log in with. We're going to create this special user. Then we're going to log in with test user. Oh, let's log in with special user. That's fine. Let's create our resource. Okay, let's get our resource. Oh, let's get our resource. Right, and we have an error. Perm middleware, whatever. Perm is not defined. Right, that's the problem. No, right, some content. And now if we log in with test user, let's see what happens here. Let me just pause this for a bit, and I'll find the solution and we'll continue. Yes, sorry, I forgot to write this. So this is a where this stuff. Inattention of my part. Right, so now, so our resource is created for test user, I guess. And if I log in with special user, which has ID 2, and I request this bit, you can only view your own resources. Right, so that's the gist of it. Now, um, if you have any questions until now, I'll pause. Right, so for the last thing we're going to see, we're going to look at Google Authentication. We're going to maybe rediscuss this next time because although this example is going to work, it might not work for you. I'm going to check it, and then if there's need to have an updated variant, I'm going to upload it. The reason is that the API, so I'm going to explain how this actually works, but the API has changed. And although I have an application which has access to a legacy API, you might not be able to do that, right? So the premise of this is that you're registered as a Google developer and that you've created an application in your developer console. And for that application, you can use various APIs, which may or may not work. Uh, if it works, I'm just going to leave it as is. Now, I'm going to have a server.js and a package.json. Because we have all this API business, I'm going to just take the package.json from my version and modify it. So it's not MySQL, it's SQLite. We're going to do that. So a couple of things. So I have .env. The reason I have .env is that some of this stuff is going to be secret, as in it's going to be my developer credentials. So you have to input your own. What you have to do is create a file which is going to look somewhat like here. Let me just find one. Where is it? Right, so sample env. It's going to need these things. Right, so it has a Google Client ID, a Google Client secret, which you get from the Google Developer Console, and a callback. Now, what's the deal with the callback? Well, we're going to use Google as a mechanism to verify identity. Now, the way this works is it works like a sort of mandate contract, right? So it's what I'm doing is whenever the user tries to enter my application, I'm going to redirect them to Google. Now, what I'm redirecting them to Google for is for them to tell Google that I have permission to read some of their data. Now, some of their data, I don't actually care about their data. What I care is that they have a Google user, right? They have a Google profile ID, which is what I'm going to use as a unified identity, and which I can use across a bunch of applications, right? If I have multiple applications, I can use the same identity everywhere. Now, After they have a little pop-up and they give me permission, Google is going to make a request to me, right? So I'm going to have a redirect to this one, which means, and in the message for this, in the request body, I'm going to get a bunch of relevant things. Like I said, since I'm not actually trying to read their data, I don't actually care about much of it. But Google is, for example, going to give me a token, which I can use, just like in our application, to make subsequent requests to request their data. Because whilst I'm going to ask for access to the minimal amount of data, I might want to see email lists or files or whatever. What I get from Google in this instance is not really all that secret, right? But it's still the principle. It's a unified mechanism. So let's look at our server. Let me just get the server and comment it a bit. Right, so our server is going to look somewhat like this. So a couple things to notice. We use Passport. Now what Passport is the just like SQLize represents the abstract idea of persisting stuff over relational databases. Passport represents the abstract idea of authentication. This means that it doesn't have anything specific to any particular approach. The specific part is going to be something which is called a strategy. Imagine it as a Google Auth driver. Now, notice that my user is really simple. I don't care about much. I care about the unique ID, which is going to be the Google ID, and the token, right? Because after Google tells me the user exists, and I check if the user exists in my database, I'm going to consider that this was a login procedure, and I'm going to give them a token to use subsequently. I'm not going to have requests to Google every time. Now, this is Google strategy. Notice that I use those three things. So client ID, secret, callback URL. And I have a callback. And the callback actually contains an access token, a refresh token. I don't care about these. What I care about is the profile ID, which I'm going to search for in the database. Either they exist. If they exist, that's fine. Otherwise, I'm going to create them. I'm going to have a token and save the user. Notice that this is a bit stranger, and the way to end it is either done of something defined, that means an error, or done of null and something, and that means there hasn't been an error. And for the rest of it, something else to note is that the user is initially going to access auth/Google, and here I have password authenticate, etc. And this is a data namespace, right? It's what part of the user data do I want to access? And this is going to be what Google sends me back. And I'm just going to reply with the token. I'm going to stop the share for a bit so I can put in the actual data. One sec, let me just find this. As well as pause the recording. So we can now install our dependencies and test everything out. We've started our server. We can go to localhost 8080/auth/Google. No, we forgot to create our things. So create, right, and now /auth/Google. And right, we're not going to see it here because I've already accessed it and it saved it. Let's just wait a bit. I'm gonna try it in Firefox. Let's close this stuff. Hopefully it starts. this. Right, so now it's going to ask me an account, and the password. And it gave me the token. Right, so I'm using Google accounts as as identities in my own application. That's about it for today. I'm going to stop the recording, and if you have any